The frequency decomposition of a uniform filter bank has uniform bandwidth subbands and has the same sampling intervals for all subbands. So here, these rectangles are representing time frequency beams. So we have uniform bandwidth subbands and the same sampling intervals for all subbands. One example of a uniform filter bank is a spectrogram, and we can use Python to plot a spectrogram of an audio file. So here we'll be using SciPy.io WAV file to load our audio and matplotlib pyplot to plot our spectrogram. We import our libraries and make some configuration for matplotlib. We load our audio file using SciPy. We convert this as stereo. We convert it to mono. Then we plot the spectrogram using most of the default parameters, just changing the number of FFT and the sampling frequency. So here we have our spectrogram with normalized frequency and the time in FFT blocks. We can play this audio file using PyAudio. So in this case, we're importing PyAudio and other libraries. We define some parameters. We create a PyAudio instance. We create a stream, and then we convert our numbers that was loaded with the SciPy to a stream of bytes, and then we write these bytes to the stream and we close the stream. So if we run the cell, we should listen . So one of the reasons I chose this audio file is not only is a classic and an incendiary song from AC/DC, but also we can see some things here at the spectrogram, and we can see this percussive sounds in the beginning, and they have this vertical characteristics. At this point here is where it enters the drums with the guitars, and we can see a bit more horizontal structure. These things can be used in a harmonic percussive source separation, so we can have some vertical filters and we can have some horizontal filters and try to separate the percussive sounds from harmonic sounds. It's a very interesting application in a musical information retrieval, and we can see these things by analyzing a spectrogram. Another way to play audio files, is a very convenient way, is using the IPython display. So you pass the name of our audio file, and then it will create this display. So it gives you these controls. You can also download your file, and it's very convenient if you want to play some files. And we can also plot a spectrogram using librosa, and librosa is a very powerful Python library for audio processing, for music information retrieval. So it offers a lot of functions. Now I'm importing librosa, and I'm loading our new audio file using librosa. So then I am again displaying if we want to play it back. So here we just passed to the display, to the audio display, the name of our file. Here we are loading our audio file with librosa. It's giving NumPy array, and we can also play this NumPy array if we pass it to the display audio and we give it the sampling rate. Then we are using librosa to calculate the short time Fourier transform with 2048 FFT points and a hop length of 256. Then we are taking the magnitude. Here we are normalizing the magnitude. Then we are creating our plot, and we're having our spectrogram. Now I'm using it's not the power spectral density, but it's just the magnitude, and I'm having the y-axis in log. So here it is. This is the class. One of the most iconic guitar introductions in modern rock by Maestro Slash. And I also chose this piece not only because it's magnificent, but also because we can also see some things in the spectrogram. So I chose this configuration. I have the frequencies in logarithmic scale, and I have just the magnitude, not the power spectral density. And we can see mostly here are the fundamental frequencies, so you can almost see how transcription of what Slash is playing. Once again, if we so it gives you a way to see very interesting how the notes are being played, and we can see harmonics, and we can see the fundamental frequencies. So these are two examples of spectrogram. So we have a spectrogram using Matplotlib. We play audio, we load audio using SciPy. We play audio using PyAudio. Then we go to LibRosa. We load audio with LibRosa. We play audio with IPython display. We plot the spectrogram using LibRosa. We calculated the short time Fourier transform with LibRosa. These are examples of uniform filter banks, same bandwidth for all frequency bands, the same sampling interval, the same time windows for all subbands.